Draw the reflection of triangle T in the line x equals 0. The line x equals 0 is just the y-axis. So when we reflect something in the y-axis, or we reflect something in any line, we're just counting the points from that line, and it must be the same distance on the other side of the line. As in, for this point over here, we have 4 little squares from the line. Therefore, on the other side of the line, we must also be 4 squares. So that's the point. And for this point, we're 2 squares away. Therefore, it must be 2 squares away on the other side as well. And for this point, it's 4 squares. So it must be 1, 2, 3, 4 squares away on the other side as well. So our reflected image is this image. A reflected image should be inverted, but the size should still be the same. 2. Draw the rotation of triangle T about -2, -1 through 90 degrees clockwise. The point -2, -1 is there. If we draw the line from that point to one point on the triangle T, we're rotating it 90 degrees clockwise. So we want to go this way 90 degrees. So we can draw another line here. That's the same length as the original one over here, and this angle should be 90 degrees. So the new point for this point is right here. So we have one point here. We can do the same for the other points. So for this one, we can rotate it 90 degrees, and it should be here. The length should also be the same from the center of rotation. So the new coordinate for that point is here. When we rotate something, the size and the appearance of the image should still be the same. So once you got at least 2 coordinates, you should be able to draw the rest of the triangle. That is like this, and like this. So this is the triangle rotated 90 degrees clockwise. B. Describe fully the single transformation that maps triangle T onto triangle U. This means that we can't do a 2-step transformation, like translate, then reflect. No, we can't do that. We need to do one transformation that directly transforms T into U right away. If we look at both triangle T and triangle U, they're both the same size. They're both upright, but they're just in different positions. This means triangle T just got moved to triangle U, and that is called translation. And if we put this coordinate and this coordinate, these 2 coordinates are the similar coordinates or equivalent coordinates on the triangle. So to move this coordinate to the other coordinate, we need to move this side by 1, then we need to move upwards by this much. So we move in the x direction by 1 square, and we move in the y direction by 9 squares upwards. Therefore, this is translation by 1/9, or 1 unit in the x direction, 9 units in the y direction.